To sustain circular motion, centripetal force is necessary. Centripetal force is an external unbalanced force directed towards the center of a circular path. Here we will look at various sources that can provide this centripetal force. And we will also look at scenarios where such force is either insufficient or not directed exactly towards the center. Let us look at a few examples of circular motion and their sources of centripetal force that keeps them going. For a slingshot, it is the tension in the rope. For a bicycle taking a turn on a velodrome, it is the normal reaction from the banked road surface. For a car turning on a flat road, it is the friction between the road and the tires. For a planet orbiting the sun, it is the gravity of the sun. For a rotor of an electric motor, it is the electromagnetic force. And for a marble being whirled in a bowl, it is the normal reaction from the bowl wall. Let us take a closer look at some of these cases. The first one we will look at is called conical pendulum. It is like an ordinary pendulum with a heavy mass, a bob, suspended from an inextensible string which is attached to a rigid support. But unlike a simple pendulum which only oscillates back and forth in a plane, a conical pendulum goes on a circular path. Thereby, its string traces the surface of a cone, and hence the name. Let us set it in motion and also study the forces acting on it. On the bob, there are essentially two forces, its weight mg acting vertically downward and the tension T in the string acting along the string. The resultant of these two forces is found to act towards the center of this circular path, and that is nothing but the centripetal force required for this motion. Next, we will take a look at a bicycle taking a turn on a racetrack which is inclined at the turn. Such a track is called a velodrome, and this is how a bicycle turns on it. You can see the road surface and the bicycle rider in the cross section over here. The forces acting on the bicycle rider are two. First, its weight mg acting vertically downward, and number two, the normal reaction from the road. Again, like before, the forces can be resolved and added, and a resultant can be found. Over here too, the resultant is acting towards the center of the track, and it provides the centripetal force required. Lastly, we take a look at a vehicle taking a turn on a flat road. As soon as it starts taking a turn, the friction between the road surface and tires comes into picture and provides the centripetal force. But what if this friction providing the centripetal force is not sufficient due to oil slick or rain on the road? In that case, circular motion will be violated and the vehicle will skid off this circular path. And what if the force is not exactly centripetal but a little off mark? In that case, the force will have a component along the velocity, and the velocity of the body will change in its path, like this planet orbiting the sun over here. So it accelerates towards the sun and then it decelerates as it recedes away. Again it accelerates and decelerates.